Okay. You realize, of course, these team assignments are really just a way for me to have some time in which to eat. Who got an answer that they like? Way in the back. Do you have an answer that you think would be convincing to other people? No, hang on a second. That's not nearly good enough. You need to come down and put it on the board. The trick to being seen, your chalk being seen in a room this big is to push hard, but don't break it. Okay. So that angle is a preference relation, right? It's strictly preferred to. Go ahead. Okay, so tell me what you say the words.
So if like A is over B and B is over A, then A must be over A.
If the transitivity assumption holds.
Yeah.
Right. So if these two things are true, which we stated, and transitivity holds, which we want to write down separately, then this must be the case. And so, which is impossible.
So 1 and 2 cannot be both true.
So 1 and 2 cannot be true at the same time. Your name is?
Rochelle.
Rochelle. Okay. Stand face the crowd. Okay. Did Rochelle just win a silver medal or a bronze medal? Thank you very much. That was wonderful. So to write out, so Rochelle implied a couple of steps that I'll just write out. The way you would do this is, sort of step 1 here would be, if A is strictly preferred to B and B is strictly preferred to A, and if A being strictly, sorry, I'm going to actually separate this out so that it's more obvious what's really going on in the proof. If transitivity holds, which means x greater than y, x strictly preferred to y strictly preferred to z, implies x strictly preferred to z, then what we're doing is we're saying A is x, B is y, B is in the first thing, and then B is y and A is z. So A is playing two roles, and that is correct. Then this is the third statement. Therefore, you get this is the third statement. You get that A is strictly preferred to A, and we can't even think about what that means, right? That's a ridiculous concept. Strict preference means that you like one thing better than another, right? If you like apples better than apples, this is not very interesting information. We don't know what does this even mean. So that's impossible. It's meaningless. So 1 and 2 cannot both be true at the same time. Okay? And you're thinking to yourself, great, you're really driving this point into the ground. Yeah. Yeah, but here's what happened is that you went into actual greater than. You let your mind slip from the curly symbol, which is preference relation, to actual greater than. So you started treating A and B as numbers. And I'm treating A and B as consumption bundles, right? So I think if I looked at your math, it would be right, because you're getting at the same concept. But it's important to remember, here I did this with straight lines because I'm actually trying to establish what transitivity means in terms of ordering a number line. What Rochelle actually meant here is she meant to use this curly symbol, which means preference. The thing is, and here's the important difference. Where did you go? Who was asking that? You. Okay. What was your name? Daniel. Nice name. Good name. I like it. One of the best. So here's an interesting thing, and then I need to stop wasting time. The greater than operator is what is referred to as a complete ordering, okay, which means that you can perfectly rank every single different number. You would never say, for example, what that means is that if two things are equal, they're actually the same thing. So if A equals A, and it turns out that, say, A is 2, and the other A is, it means that they're the same number. If you are indifferent between apples and pears, it means that they rank at the same level. It does not mean they're the same thing, okay? So the, well, go ahead and pick that phone up. This operator, the preference operator, the strict preference operator, establish what is called a partial ordering, as opposed to a complete ordering. You can't perfectly rank every single option, but you can at least establish levels, right? Indifference surfaces, indifference curves. You can get all things lined up into this category I'm indifferent, this next category I'm indifferent, but I like them all better than the last category, okay? So that's what this accomplishes for us, but that's why you can't actually do math with this thing. Because it's not actually a mathematical operator per se. I mean, sorry, it's not a numerical operator like this. It doesn't act on real numbers. It acts on consumption bundles. Okay. We've slipped through the ice. We've gone too deep. Okay, so good. So I'll just finish up. Then A is strictly greater than A. And then this little thing, the crossed swords, that means, whoops, that's a contradiction. Okay? And you write that, and then you get to write QED, which stands for end of proof. It doesn't actually. It stands for quod erat demonstrandum, which means thus it is demonstrated. Okay, what's the point of all this? The point is this, okay? And you can take this to the bank. This is an extremely important and central concept in behavioral economics. Preference reversals, going from I strictly prefer A to B to the reversal of that, I strictly prefer B to A, is a smoking gun for a violation of rationality, because you cannot have rationality and a preference reversal at the same time. Mathematically, sort of by sort of like you can prove, in other words, using logic, that those two things cannot be true at the same time. So we call that a smoking gun. Now, for those of you who are not steeped in the American idiom, there's the Wikipedia link for the term smoking gun. What it means is, if someone is on the floor dead with a bullet wound in their head, and I have a gun with smoke coming out of it, it kind of suggests pretty strongly that I just shot that person. Okay? So a smoking gun means very strong evidence, and in fact, in this case, it's completely conclusive evidence. If you can demonstrate that something is a true preference reversal, you have proved that rationality does not hold, cannot hold. Okay? The point of all that is, we're going to go looking for preference reversals, right? We're going to go looking in data sets and experiments and all kinds of places in human behavior for preference reversals. And then once we see preference reversals, it's kind of like if there's an avalanche and you see a ski pole sticking up out of the snow, you think to yourself, I'm going to dig here, there's probably a dead body here. So we look for preference reversals. So what do I mean by that? Okay, apples and pears is not that interesting. Here are the kinds of things that we look at. Suppose we find somebody, let's call them, I don't know, Dan Ackland, who at some point in time t chooses to buy a gym membership on the basis of preferring, at time t, to go to the gym in the future over not going to the gym in the future, right? I have two choices in the future. I got a choice to make in the future. Should I go to the gym or not? I buy a membership because that means I pay money now, I get to go to the gym for free in the future. So this is based on the assumption in the future I will prefer going to the gym over not going to the gym. Then the future comes, and I no longer want to go to the gym. I prefer not to go to the gym, okay? So this is a preference reversal. Now you might say, well, that's because you weren't tired when you made the gym decision, and now you're tired. Okay, I'm going to wave my hands at all of that and say, under the ceteris paribus assumption, I claim that I could find somebody, that I could wake somebody up at 5 o'clock in the morning, which is when I get up, and never want to go to the gym at 5 o'clock. But I might be willing to buy a gym membership at 5 o'clock. I believe that I'm that crazy. So my preferences change over this specific decision in the future, depending upon whether the future has arrived or not. Okay, we're going to talk about that a lot. That has to do with irrational time preferences, your preference for the future versus the present. Okay, here's another example. So that's like the entire second section of the class. Here's another example. I'm sorry if this is a little off color. unfortunately, it's all too true. Suppose we find someone who, in the throes of romantic love, prefers the idea of being married to their beloved over not being married to them. Then they get married, and they discover, lo and behold, they have a different preference now, and wish very much that they were not married. Well, you could think of this as like the marriage divorce pump. Do any of you guys remember who Richard Burton and Elizabeth Taylor were? They were like two famous Hollywood actors and actors. How many times did they get married to each other? Like 7 times? Like really, literally? So anyway, so this is an example of what's referred to as the hot-cold empathy gap, which is another way of saying that when I'm in what is referred to as a hot state, like hunger or craving a drug or some sweets or being in love or being sexually aroused, which is one that has been studied quite a lot, that I'm unable to really grasp what my preferences will look like when I am no longer in that hot state. So if I'm trying to make a decision that will be binding on a future version of me that is in a cold state, right? But I'm doing so in a hot state, I'm making a choice for a cold state. I make the choice differently depending on whether I'm in a hot state or not. You might think, yeah, that's fine. You just make different decisions depending on whether it's a hot day or a cold day. But you're making a decision about a cold state in 2 different situations, and you're making the decision differently. It's a problem of misprediction. You're failing to understand the way in which your preferences will change. Okay, so it's a prediction problem. We'll talk about that for a couple of lectures. A third example. Where'd it go? Thank you. Third example. Let's imagine another hypothetical character. If you want to, you can also refer to this guy as Stan Acklin. When you're climbing up a cliff, you prefer a risky gamble, climbing a cliff that is beyond your usual abilities, to a non-risky gamble, hanging out with the squirrels at the bottom of the cliff. As you are falling to the bottom, you realize that your true preference was for the non-risky gamble. It's true of a lot of behavioral economists that we get a lot of our insights from our own ridiculous behavior. So anyway, that's that. Those are all examples of preference reversals. We're not actually going to look at the choice over whether or not to go rock climbing, but we're going to look at various different types of decisions in which we see preference reversals of one kind or another. And as long as we can convince ourselves that they really truly are preference reversals and not something else, then we say, all right, this is an anomaly. This is a case of non-rationality. All right. So now we're going to look at indifference curves. We're going to go back to indifference curves. Yeah, I think that'll work. Indifference curves that intersect, right? Problem set, hopefully all of you got to the point in the problem set where you had a graph of 2 indifference curves that intersect. Same utility function, different endowment points, intersecting indifference curves. These are strictly a violation of rationality, of transitivity in particular. One of the things that you will have learned in intermediate micro is that under rationality, indifference curves cannot cross. Yeah? So let's actually poke into that a little bit. Indifference curves that cross violate rationality because they can't be used for ranking purposes. They also, and which is closely related, they allow for preference reversals, which is kind of the point. So here's what I mean, and this is what you guys, this is familiar, right? This is what you guys came up with? Okay. So here I am, I'm going to call this E1, the first endowment, this is E2. So this is the same person in 2 different universes, one in which they have one endowment, the other they have another endowment. From the perspective of endowment point 1, A is strictly preferred to B, all right? Why do I know that? Because I look at the indifference curve that A is on, and I don't look at the other indifference curve, because that would just make my head spin, but I look at B, it's below. And we know that if a point is below an indifference curve, it's because it's less preferred. And vice versa, from point E2, B is strictly preferred to A, right? Because A is below the indifference curve that passes through B. Fine. So that's a question of ranking, right? That sort of is the point about not being able to use these indifference curves to rank things. If indifference curves nest together nicely in the way that you were shown, then you can think of them as contour lines on a mountain, and the height of the mountain is your ranking. I want to sort of drive home a different way of thinking about this, which is this idea of preference reversals. So I'm going to actually switch colors to do this. Oops, all right, fine. So there was E1 and there was E2. Now, suppose I think about this in terms of buying prices and selling prices. All right? You start out from your endowment point. That's this many mugs. I'm going to move you to A, which is a decrease in mugs, and I call it delta M. So you're selling at the moment, right? How much money you would be willing to give up, right, which is this, that is your minimum willingness to accept. We'll call that delta dollars, which is another way of saying that the slope of that indifference curve is your willingness to pay. This you already knew. So from the perspective of E1, when you're endowed at that point, A is a sell at an acceptable price. Okay? Meanwhile, if I then say, let's consult this person under the conditions of being endowed at point E2, right? So then what I have is that the difference in mugs is much greater. This person is being asked to sell a larger number of mugs. But the question is the amount of money they would have to give up, the amount of money that they would need to be paid in order to let go of that many mugs, acceptable to them or not? Right? So the question is, another way of asking the question is the slope of that dotted line, right? Because delta dollars over delta M is just the slope of that line, rise over run. Is the slope of that line an acceptable price to them? And the answer is no, it's too high. The slope of that line is steeper. In absolute value, it is greater than the slope of their actual indifference curve, which is another way of saying that from the perspective of the second endowment point, A represents a sell at an unacceptable price. Okay? So to say I would rather have A plus some money, plus the price of A at one point, but at another point I would rather, to say I would, from my perspective, I would be willing to buy the bundle A. I'd be willing to trade what I've got now for the bundle A, but under another set of a different endowment, I would not be willing to trade my current bundle for A. It's a preference reversal, right? One case I prefer to buy, in the other case I prefer not to. So this represents a preference reversal, and likewise these 2 statements represent a preference reversal. Okay? Fine. Rationality means stable rankings, means preference reversals, means no preference reversals, means no intersecting indifference curves. Okay? Preference curves intersect. You have an absolute clear proof of a preference reversal, a failure to rationality. Now, you've seen this in a problem set, but the fabulous thing about a problem set, from my perspective, and the problematic thing from the standpoint of the scientific process, is that I made the problem set up. Right? What we need to do is to consult reality. Any questions about this? Does that all make sense? All right. So we don't yet have incontrovertible proof of intersecting indifference curves. What we've seen in the mugs and pens the mugs and candy bars experiments suggests very strongly that if we could identify people's indifference curves, they would intersect. But we don't yet have proof of it. But we're about to. The next study we're going to look at, which is another Jack Knetsch paper, he went out and he did an endowment effect field experiment that was a bit more elaborate. Now I say field experiment because he did it outside of the lab. It's basically like an outdoor lab experiment. Here's what he did. Try not to laugh. He went to a swimming pool. And he went to a swimming pool during swim practice for little kids. And so he had this captive audience, which was the mothers who were waiting for their kids. Okay, that was his sample. 20 mothers waiting for their children at a swimming pool. And he broke them up into two groups, group 1 and group 2, and he randomly endowed them with two different endowments. The first group got an endowment of $4.50. I guess that's Canadian because he's from British Columbia. And the second group got 5, I love this, reasonably high-quality ballpoint pens. Okay? So two different endowments. And you can think about each of these as a bundle of pens and money. One is 5 pens, no money. The other is $4.50, no pens. Anybody want to guess what the going price of a reasonably high-quality pen was at the time in 1992? 90 cents. Why? Because, of course, Jack Knetsch would select a number of pens and an amount of dollars that would rule out the income effect as any part of this. Great. And what does he do? He says this. I'm going to ask each of these mothers separately. They must have been just looking at him. I don't know. He's going to ask them their willingness to pay and willingness to accept for different quantities of pens, starting from their endowment point. So starting from 5 pens and no money, or whatever money you've got in your checking account at home, would you be willing to accept a trade for this many pens and this much money, or this many pens and this much money? Okay? So he asks over and over again a series of take it or leave it offers. Yes or no? 17.8 offers on average. Like you're just dying for your kid to get out of the swimming pool. Would you accept a trade of this much dollars for this many pens, or vice versa? And then what he does, and this is really clever, is he plots the acceptances. Yes, I would. I'd be willing to trade my initial endowment for, I'll give up this many pens for this much money, or if I was endowed with money, I'll give up this much money and gain pens. So if you accept, he marks it with an X on a map of indifference curves, and if you reject, he marks it with an O on a graph of dollars and tens, and then you plot the difference in curve implied by those X's and O's, and you average it out across the groups. So let me show you what I mean. Here's a map. This is actually real data for one of his subjects. And he says this, okay? The first offer asked if the participant would prefer to keep the 5 pens or to give all of them up for $7. So that would be, so this is a person who is pen endowed, right? So this person is being asked whether or not they'd be willing to sell different numbers of pens in exchange for different numbers of dollars, yeah? Okay, so this person is a seller, but that isn't actually what matters. What actually matters is that this person is endowed with pens, okay? So they are pen endowed. What matters here isn't whether they're buyers or sellers endowed, but what their endowment is. So the first question he asks is, would you exchange this bundle of pens and money for this bundle? Give them all up and I'll give you $7. And this person said, sure, no problem, an X, okay? And then he goes and asks other questions. So let me focus in on one. This one right here, right? Here's the same individual being asked, would you be willing to sell, what was that? Sell 2 pens, right, for $3.50, okay? And this person says no, okay? Now, think about the definition of an indifference curve. This indifference curve is intended to mark all of the bundles of pens and money that would give the person the same utility as their original endowment, okay? It's all of the things that this mother would rank equally. If she says no to selling 2 pens for $3.50, what that means is that her utility for the bundle 0.5, which is her endowment point, is greater than the utility she gets for a bundle of $3.50 and 3 pens, right? So all of the points on the indifference curve will give her more utility than the bundle 353, which means her indifference curve must pass above that point, okay? So her indifference curve must go above all of the O's and below all of the X's. And that allows, Knetsch, to map out, and I love this because like 1992, so you guys most of you weren't born, which is, when you get to be 45, try not to think about when your students were born. It's really depressing. I was in college in 1992, and I was very, very fortunate to have access to an extremely high-tech lab in which there were 2 of the very first Macintoshes, right? Back when Macintosh stood for most applications crash, if not the operating system hangs. Which is one of my favorite acronyms. Knetsch did this by hand, right? He went in and sketched it in by hand, which is one of my favorite things about this diagram. And then what he did was that he averaged those things out and came up with that. He averaged them, right? So this is an indifference curve for a single person who was pen endowed, who was giving up pens for money. And then he did the same thing for all 10 of the people in that group, and a similar thing for all 10 of the people in the dollar endowed groups, and he came up with this. Okay? So he calls this IM for P. So this is the indifference curve for someone who's trading money who's receiving money for pens. Okay, we're going to call that person a seller. They are pen